Hi everyone, so those questions where you have to work back to find, say, sigma squared or mu are quite difficult, so here's another shaky handheld video to show you how I go about it. Now, first of all, you need to understand what you know in the question. So in this case, let's just say that x is distributed normally with a mean of 5 and some variance sigma squared, and we happen to know that the probability that x is greater than or equal to 7 is equal to 0.05. That's what we know in this particular context. I'm just making this up as I go along. I always write down what I know for these questions because A, you never know when that can get you a bonus mark, and B, it helps me frame my understanding of what it is I have and what it is I want to work towards. My next step is I would suggest you substitute for Z using as much algebra as you can to get as close as you can and to look that score up in the table. Then isolate what you need and off you go. Now, because that by itself is not particularly useful, let's do this in a specific context, more shaky handheld stuff. Okay, so we know that x is distributed normally with a mean of 5 and some variance sigma squared, and we also know that the probability that x is greater than 7 is equal to 0.05. So you can see here I drew my little normal curve. I still do this 15 years after learning how to do this stuff. I still draw these curves. Again, you never know when this will get you a bonus mark. If you're doing an exam question, you forget to carry the 1, you make some mistake. I see that here. I see that you understand what's going on, and I'm much more likely to be able to find something, smooth it out. It just demonstrates in another way what you know. Now, because it's in the upper tail here, we can say that this is really the same thing as saying the probability that x is between its mean, 5, and 7, the given number here, is equal to 0.45 because everything to the right of 5 there is equal to 0.5. So here I'm substituting in my my z-score, so 7 minus 5, x minus mu, all on sigma, is equal to 0.05. Go look it up in the table. I think you'll find it's 1.645. That is the z-score. So if I just, just draw another table, normal distribution here. So now this is for z now. We want some sort of z in which that is equal to 0.05, and you'll find that's equal to 1.645. It might not be exactly equal to that on your table, but it'll be somewhere between 1.64 and 1.65, and that's why I just use 1.645. So we've got here 7 minus 5 on sigma, so really that's just 2, and then we put sigma on the other side here, so 1.645 times sigma. If I then say take the 1.645 over to this side, and that we have sigma is equal to 2 divided by 1.645. And that's how I'd go about getting that answer in these types of questions. I hope that was helpful. Let me know if you can apply this to the questions in the text, and we'll work through any other questions you might have.